Hello students, welcome back. Today we will solve a classical problem on finding the eigenvalues and the corresponding eigenvectors of a matrix. See, I picked this particular question from the VTU model question paper aimed at the electronics and electrical stream of students, and it also appears in the older 18, 21, 22 VTU schemes. And as I always do, I will show everything in simple, easy steps. So follow closely and practice along with me. See, my dear friends, all the related videos from the VTU schemes, that is 17, 18, 21, 22 and the first 25 schemes are organized into playlist and courses on my YouTube channel Mudassir Academy. The links you can find in the description below. So, if you follow the courses and practice regularly, okay, with full dedication, you will be well prepared for the final examination and aim for more than 90% of the marks. Okay, so get your pen and notebook ready. Let's start solving for eigenvalues and the corresponding eigenvectors in a very easy and clear way. So don't forget to like, share this video with your friends and classmates and subscribe if it helps. So let's begin doing the problem here. See, the problem here is find all the eigenvalues and the corresponding eigenvectors of the matrix A is equal to 8 minus 6 2 minus 6 7 minus 4 and 2 minus 4 3. Now, you need to find the eigenvalues and the eigenvector. So, we will do step by step in a very easy way. So, please pay close attention here because the question is of 67 marks. Okay, so each step matters. So, first we will find the eigenvalues. To find the eigenvalues, simply we will write first a characteristic equation. Okay, now I write here the characteristic equation is determinant of A minus lambda into I equals 0. So, we need to do nothing here, simply write a determinant and along the principal diagonal 8, 7, 3 apply minus lambda, minus lambda, minus lambda. That's it, simple. Don't take tension here. So, that means we can write here A minus lambda into I determinant is equal to determinant of, see what I told, along the principal diagonal apply minus lambda, minus lambda, minus lambda. That's it. So, 8 minus lambda minus 6, 2 minus 6, 7 minus lambda minus 4 and last 2 minus 4 minus 4 and along the principal diagonal 3 minus lambda equals 0. That's it. Okay. Now we need to solve this determinant and find the values of lambda. So there is a traditional method of doing it, okay, in which you will simply waste your 15-20 minutes of time and mostly you will get wrong answers. That is plus 8 minus lambda into 7 minus lambda into 3 minus lambda minus 16 minus plus 16 to minus 6 into 3 minus lambda plus 8 so on. Okay, it's waste. So I'll show you a simple shortcut method here. So simply use this formula I show here. See, 3 by 3 matrix. So this is what I write here better, lambda cube minus sum of diagonal into lambda square plus sum of principal minus, what is that? Sum of principal minus into lambda cube, lambda square into lambda minus determinant of A equals to 0. First, lambda cube, see here implies this will be lambda cube minus, what is sum of diagonal? See, 8, 7, 3, 8 plus 7, 15, 15 plus 3 is 18, that's it. So, minus 18 lambda square plus, see this sum of diagonal is also called as trace. Now, next is sum of the principal minus, okay. So, what does it mean? See, very simple. I will write here, this will be nothing but, see, when I am finding principal minus means what are the principal? 8 minus 7, 7 and 3. So, for 8, do nothing. Listen carefully, practice with me here. See, for 8, leave this 8, this column, this row. What is that? 7 3s are 21 minus of minus into minus plus 4, minus 4 16. How much? 5. Getting? Then next, what is next minor? What is next principle? 7. The minor of 7 is what? Leave this row which includes 7 and a column. 8 into 3, 24 minus 2 2s are 4. How much? 20. And lastly, 3. Leave this column, leave this row. Okay, 8 7s are 56 minus into minus plus 36. So minus 36. How much? 20. So add all, we'll get 45. That's it. So plus 45 lambda minus determinant of A. Will better make use of calculator. Don't take any risk, make use of calculator. I show here. So I have the FX 991 CW here. You can try with your other calculator also. So as usual, we'll go to home and we go to calculate. Okay, go to settings and do the reset. The best practice. Initialize all. Okay. Now again, since we are doing it matrix, go to okay, down again. Yeah, matrix. Now press tools. We'll enter matrix A. So matrix A is 3 rows. Okay, then column is again 3. Confirm. So write a matrix here. 8 execute minus 6 execute 2 execute minus 6 execute 7 execute minus 4 execute 2 execute minus 4 execute 3. So AC. I enter the matrix here. Now press AC and press catalog. Matrix. Okay, go down. So we need to find a determinant here. So press matrix calculator. See here in matrix calculator there is determinant. Okay, determinant is what? Again catalog matrix A is equal to 0. That's it. So minus 0 is equal to 0. Now again lambda cube minus 18 lambda square plus 45 lambda is equal to 0. To solve this equation, again simply we have to find out 3 values of lambda. Again simply make the use of calculator. So again go to home. You need to go to where equations here now. Okay, go to equation and you're solving a polynomial here. So polynomial ax cube plus bx square cube is there. So select the second one. So put the values here. Lambda 1 lambda cube. Execute minus 18. Execute 45. Execute constant is 0 is equal to. See, we get x1 is 15, 3 and 0. 3 roots. 15, 3 and 0. So I'll write that implies what's that? Lambda is equal to 0, 3 and 15. Now, this 0, 3 and 15, all the values of lambda are called as what? They are called as eigen values. Okay, so these values are, we call it what? I write here, eigen values. So let me underline it. These are what? The eigen values. Which are eigen values? Lambda is equal to 0, 3 and 15. Now, for this eigenvalues, we need to find the corresponding eigenvectors. Each value will have its corresponding eigenvector. For 0, different eigenvector, for 3, a different eigenvector, and for 15, it is a different eigenvector. Let's see how to do it. I hope you clearly understood this method. Fine. So, usually what they do in an examination, they will, they'll apply the old traditional way of solving determinant, and many cases you go wrong in plus or minus sign, you won't get a correct eigenvalues. So make the smart use of a scientific calculator and reduce time and get the exact answer. That's what I am teaching you here. Okay, fine. Now let's find the eigenvectors. So to find the eigenvectors, see, as you see here, this determinant clearly indicates system of equations. It is x, y and z. So if I write the equations here, I can write this as like this. See, 8 minus lambda into x minus 6y plus 2z is equal to 0. Then minus 6x plus 7 minus lambda into y minus 4z is equal to 0, and lastly 2x minus 4y plus 3 minus lambda into z is equal to 0. This clearly indicates a system of equation. I write here system of equations. Now I derive from this. Okay, because this each column represents x, y and z. Fine. Now how I am going to make use of this to find the eigenvectors? Listen carefully, watch here. So we have three cases. One is the eigenvalues are lambda is equal to 0, lambda is equal to 3 and lambda is equal to 15. For each eigenvalue there is a corresponding eigenvector. So first what we'll do, we'll take, first case I'll take, let lambda is equal to say 0. Okay, the first case is what? Lambda is equal to 0. For this lambda is equal to 0, I will put here in this system of equations. Fine. So I'll take this case first. Case 1. Okay. So put here in lambda is equal to 0 in this equation. So when I put lambda is equal to 0 here, see 8 minus 0 will be what? It implies 8x minus 6y plus 2z is equal to 0. Fine. Then minus 6x, 7 minus 0 is 7 only, plus 7y minus 4z is equal to 0, and lastly 2x minus 4y, 3 minus 0 is 3, plus 3z is equal to 0, right? Fine. So what I will do here is, from this I will find the three values written x, y, z, that is the eigenvectors. Okay. So how shall I do it? See, very simple. Listen carefully again. Select only the two rows. Which rows? See, I will select this. Any two you can select. I will select these two rows. This and this I select. So you select that, write it. See what I am doing it. Write like this. See, 8 minus 6, 8 minus 6, then minus 6, 7 and 2 and minus 4. Fine. Now from this, what I will do here is that, see carefully, I will take this for say x, y and z. I am showing a very simple way here. Now the rule of cross multiplication simply works like this. Listen to me carefully. It's just like a determinant. Okay. Now first x divided by, fine. See, when I take, see, I taken from here 8 minus 6 minus 6 7 2 minus 4. Take it correctly. Now for x, leave this whole, leave the x column. See, and determinant 6 minus 6 into minus 4, 24 minus 7 2s are 14. Simple. Take it. Second, for the second, always the second term is minus 5, always, because see, plus minus plus as a solid determinant. I am showing you the very easy way. Minus 5 upon, again for minus 5, leave this y column. 8 into minus 4 minus 32 minus 6 into 2 minus 12, so minus of minus plus 12 is equal to z divided by, leave this. See, 8 and the 56, correct, minus 6 into minus plus 36, so minus 36. Done. So I have this here now. That will be now, if I write it here, this will be what? X by, what does that tell me? 24 minus 14 is what? 10 equals minus y by minus 32 plus 12 is minus 20 is equal to z by 56 minus 36 is what? 20. That's all. Correct. Now, this will be again, this reduces to what? X by 10 ones are 10 is equal to, see, minus minus cancel, plus 10 twos are 20, and lastly 10 twos are 20. So, the Dawn values whatever I get here 1, 2, 2 are the eigenvectors. So, I write here that implies for lambda is equal to 0, the eigen vectors are x naught is equal to, always the eigenvector is a column vector. So, 1, 2, 2, 1, 2 and 2. That's it. This is my first eigenvector for lambda is equal to 0. Now, second case, let lambda is equal to 3. Okay. So, I choose for what? Lambda is equal to 3 now. So, for lambda is equal to 3, tell me what? Same circus will do. What first? Put it here. So, when I put lambda is equal to 3, we get, put here. So, 8 minus 3 is, it implies 5x. 8 minus 3 is 5 minus 6y plus 2z is equal to 0. Then minus 6x. 7 minus 3 is 4 plus 4y and minus 4z is equal to 0. Lastly, 2x is not required because I told you take only the first two rows, but to show the examiner to get mass, I have to show it. Do whatever I tell you perfectly, you will get the exact mass. Okay. So, 2x minus 4y. Lastly, 3 minus 3. Lambda is equal to 3, right? 3 minus 3 is 0 plus 0z is equal to 0. Okay. It's not required, but taken it 2x minus 4y plus 3. Okay. So, as I told you, take the first two rows. That's enough for RCM, that is rules of cross multiplication. Okay, this is called as what? Rules of cross multiplication, RCM. Fine. Now, what I told you now, for this take only two rows, and for that take, write like this. It will be very easy for you. 5 minus 6, then minus 6, 4, then 2 and minus 4. So, tell me, what shall I do now? As I told you clearly, take this for x, y and z. Okay. Fine. Now, apply the RCM, rules of cross multiplication. So, for that, x whole divided by what I told, again listen carefully. For x, leave the x full items column. 6 into minus 4, minus 6 to minus 4, sorry, minus plus 24, minus 4 to the 8. Again, second term is always minus. Remember it. Okay. Always second term is minus. Leave the y. 5 into minus 4 is minus 20, minus 6 to 1 is minus 12, so plus 12. And lastly, z divided by, what is that? Leave the z column here. See, 5 4s are 20, minus 6 into minus 6 is what? Plus 36, so minus 36. That's it. So, I hope you're getting it clearly. Okay. If not, again, rewatch the videos till you get it. Now, again, this will yield implies x by 24 minus 8, 16 minus y by minus 20 plus 12 minus 8 equals z by 20 minus 36 minus 16. That's it. So, again, so I can divide this whole by 8. So, when I do that, I get implies x by 8 to the 16, again minus minus become plus, y by 8 1 the 8 is equal to z by 8 to the 16, that is minus 2, correct? 8 to the 16, minus minus become plus, and minus 16 is 8 minus to the 16. That implies, therefore, that implies for, write here clearly, therefore, that implies, therefore, for lambda is equal to 3. Okay, the eigen vectors are, I think says x1 is equal to, what are the vectors? 2, 1 minus 2, 2, 1 minus 2. That's it. Fine. Lastly, for case 3, that is, let lambda is equal to 15. We'll take this case now. So we'll find for now lambda is equal to what? 15. So for lambda is equal to 15, again, what to do? Put 15. Watch carefully. Every step is same. Only you need practice and practice and practice. Again, lambda is equal to 15. Put it here. What is 8 minus 15? Minus 7x. So it implies we have minus 7x, correct? Minus 6y plus 2z is equal to 0. And minus 6x as it is. 7 minus 15 is minus 8y. And lastly, minus 4z is equal to 0. Then 2x minus 4y. 3 minus 15. What is that? 3 minus 15 is minus 12z is equal to 0. Correct? Okay, we have this now. Now, again, same thing, what I told, we need to consider only the first 2 rows. That's enough for RCM, that is, rules of, by applying the rule of cross multiplication. So, again, see, I am writing it here, since space, I am lacking space here. You can write it down clearly in the examination. Okay. Now, again, 7 minus 6, first 2 rows as I told, minus 7, minus 6, minus 6, minus 8, 2 and minus 4. As I told you, this for x, y and z. Each step write carefully. Now, x, that implies x divided by. Sorted. Now you can yourself do it easily now. So please tell me what to do. Leave the sign x column here. Minus 6 into minus 4 is 24 minus 8 into 2 minus 16. So minus plus 16. Be very careful about the signs while following this determinant method. Okay. Now next is minus y. Always y is minus. Pay attention. Focus here. Always y is minus a second term. Then y minus 7 into minus 4, 28. Then minus of minus 6 into 2 is minus 12. So minus plus 12 is equal to z divided by, lastly, leave the z column, minus 7 into minus 8 is minus 7 minus plus 56, minus into minus 6 is minus plus 36. So it will be minus 36. Fine. So it implies x divided by 24 plus 16 is, it is 40, minus y by again 40, again z by 20. Now it's done. So I can divide by 21s are 22s are 22s are 40. So that implies x by 22s are 40. See, here minus is there. So minus and plus, minus or plus is minus only. 20. I'll write first. Minus y by 22 are 40 again. And lastly, z by, what is that? 21s are 20. Therefore, I can write for lambda is equal to 15, the eigen vectors are, I taken this x0, x1, and I take this as what? x2 is equal to, what are they? 2. See here, minus or plus is minus. Okay, so second is minus 2 and 1. That's it. these are the eigenvectors. So as simple as that. I hope you clearly understood. I have explained this in a very simple way so that I can solve it perfectly and solve it in less amount of time. But accuracy and speed will only come by practice, practice and practice, as I always keep on telling. So once again, first what you do, when the problem is given, what a problem, we find a characteristic equation, apply minus lambda to diagonal, then without wasting time, without solving the tedious equations, make use of this sum of lambda cube minus sum of diagonal into lambda square plus sum of principal minus into lambda and minus determinant A. So for finding determinant, use a calculator, very easy, I showed you. Okay, so get eigenvalues. So now for each eigenvalue there is corresponding eigenvector. So we put first we put lambda 0 in this, we make an equation out of this, okay, and in which we use only the first two rows. That's enough for RCM method. I hope you understood this now clearly. So I explained it here again in a more easy way how to take it. So for this x, 8 minus 6 minus 6 7 and 2 minus 4. For finding for x, don't take the x values, only take y, divide by minus 6 minus 4 24 minus 14 and so on. Okay, so for lambda is equal to 0, you get eigenvectors as, underline it, 1 2 2. Then for lambda is equal to 3, you get this eigenvector, and lastly for lambda is equal to 15, you get 2 minus 1 2. That's all. These are the values. Okay, so I hope now you have clearly understood how to find the eigenvalues of the eigenvectors and the corresponding eigenvectors of the given matrix. This question is important. The same question they may ask repeatedly in examination. So please watch the video continuously, repeatedly and practice this well. So that's all friends for today's video. So I will be coming with more videos. So if you have any problems you want me to solve, then please drop a comment below. I will be glad to help you. So that's all for today. So see you in the next video. Till then, happy engineering, be confident, keep practicing. See you in the next video. Bye.